Good morning to one and all present here. In the today's presentation, we are going to discuss about the global system for mobile communication in mobile computing that comes under the class 2. What is GSM? GSM stands for Global System for Mobile Communication. It is a digital mobile telephony system that is widely used in Europe and other parts of the world. GSM is a second generation cellular standard developed to cater video services and data delivery using digital modulations. GSM uses variations of time division multiple access and is most widely used of the three digital wireless telephony technologies that comprises of TDMA, stands for time division multiple access, GSM, that stands for Global System for Mobile Communications, and CDMA, that stands for collision code division multiple access. GSM digitizes and comprises the data that then sends it down a channel with two other streams of user data, each in its own time slots. It operates at either 900 MHz or 1800 MHz frequency band. The services that are all provided by the GSMs are teleservices that includes the mobile phones and emergency calling when we are making a phone calls to our neighbor or to our friends through the mobile phone. So that provides that kind of services are called as the teleservices that are provided by the GSM services. Bearer services are data services. So what are the bearer services that can be provided by GSM services are? That includes the short message services, SMSs we are trying to send, fax, voicemail and email. So these are all the data services that are provided by the GSM architectures. Some supplementary services are also provided by the GSM that are called as incoming and outgoing calls, a call forwarding, call holding, call waiting and call conferences are provided by the GSM services. So these are all the main three services that provided by the GSM architecture. That GSM architecture, this is the architecture of the global system for mobile communications that comprises of three segments, namely called as the radio subsystem, network subsystem and operation subsystems. In the radio subsystem that contains the radio cells and base stations, substations. That contains this radio cell contains the mobile station and base transceiver stations. The information forwarded by the mobile stations are the data generated by the mobile stations are forwarded to the base transceiver station. The base transceiver stations will forward the data to the base station controller. If the destination node is available within this particular base transceiver station, the data will be directly forwarded to the destination node. Suppose if the receiver node is available somewhere else, in the sense that the base station controller will take care of identifying the appropriate destination node's base transceiver station. Suppose if it is not able to identify the base station, if it is not able to identify the destination node, that will forward the data to the default base station transceiver station, that will forward the data to the particular node and it will try to change the data. So in the network subsystem, it contains a n number of base station controllers are there. Suppose if everything is available in the within the particular base station controller, the data will be forwarded. Suppose if it is available outside the base station controller, in the sense the data will be forwarded to the base station controller via the MSC, mobile switching center. Via this MSC it will be forwarded to the base station controller. Again it will try to identify the appropriate node. So those things will come under the radio subsystem. Followed by the next segment is called as network subsystem that contains the mobile switching center, visitor location register, home location register, VLR and HLR, and gateway mobile switching center, and IVF that contains the ISDN, PSDN and PDN. So these are all the segments that are comes under the network subsystems, which will receives the data. When it wants to transmit the data outside the network, the mobile switching center will support. When the node is traveling through the mobile switching center, that has to be in the visitor location register or home location register. The home location register will maintain the detailed information about the mobile station. Suppose if the new node is arriving at that particular mobile switching center, and that information will be if it is going to stay there for a particular amount of time, that will be maintained in the visitor location register for a particular amount of time, and it will transmit the data. So the difference between visitor location register and home location registers are. Visitor location register will maintain the detailed information about the mobile switching mobile station for a particular amount of time. In case of home location register, it will maintain the detailed information about the particular mobile station. And GSM MSC stands for Gateway Mobile Switching Center. When the data is not available, the destination node is not available under the base station controller, that will be taken care by mobile switching center. If the destination node is not available under the mobile switching center, that is a mobile switching center in the sense, it has to go for the default or identifying the route for identifying the destination node in some other way. That can be done by using the Gateway Mobile Switching Center. So these are all the portions that are coming under the network subsystem that contains the signaling, ISDN, public switched telephone network, and PDN. Followed by that, the next segment, next area is called as Operation Switching Center, that contains the EIR, stands for Entity Identity Register, authentications, and operation maintenance and controls. So these three portions are coming under the OSS, that is Operation Subsystems. So about that only we have briefly explained. So this radio subsystem contains the radio cell. That radio cell contains the mobile stations and base transceiver station and the n number of base station controllers. A base station controller contains the n number of base transceiver stations, and radio subsystem contains the n number of base station controllers. Mobile station, as we know that the mobile station is made up of two entities that contains the mobile equipment and subscriber identity module. Everybody knows that SIM card, namely called as a SIM. Mobile equipment is called as ME, that contains the portable vehicle mounted handheld devices uniquely identified by an international mobile equipment identity, simply it is called as IMEI number, and voice and data transmission, monitoring power and signal quality of surrounding cells for optimum handover. The power level of the mobile station is 0.8 watts to 20 watts, and the characters and total number of characters that can be carried by the short message service is 160 characters it can. So SIM is nothing but subscriber identity model that contains a smart card, a single chip. So a single chip will be there, that computer containing the operating systems, a file system and applications, and it is accompanied by the protected by pin. Pin number will be there, that is owned by the operator, and the SIM applications can be written with SIM toolkit. Mobile stations are combined with the subscriber identity module. Smart cards contains the international mobile subscriber identity, allows the user to send and receive calls and receive other subscribed services, protected by a password or pin. It can be moved from phone to phone, or it can contain the key informations to activate the phones. Base station systems are radio subsystem that we discussed, base station controller and the base transceiver stations. The base station controller provides all the control functions and physical links between the mobile switching center and the base transceiver stations. It is a high capacity switch that provides functions such as handover, cell configuration data, and control of radio frequency. Power levels in base transceiver stations. A number of BSCs are served by an MSC. Base transceiver stations handles the radio interface to the mobile stations. The base transceiver station is a radio equipment that needed to service each cell in the network. A group of BTS are controlled by the base station controller. Those things we discussed in the architecture diagram itself. So base station system or radio subsystem contains the MSC, BSC, MSC and Internet. BSCs are connected with the base transceiver stations. MSCs are connected with the n number of base station controllers. So the next portion is nothing but the network subsystem that contains the VLR, HLR, MSC and GMSC IVVF. So home location register. The home location register is a database used for storage and management of subscriptions. The HLR is contained the most important database as it stores permanent data about the subscribers, including a subscriber's service profile, location information and activity status. A mobile services switching center. The mobile switching MSC performs the telephony switching functions of the systems. It controls calls to and from other telephony and data systems. It also performs such functions as toll ticketing, network interfacing, common channel signaling and others. Visitor location register VLR is a database that contains a temporary information about the subscribers that is needed by the MSC in order to service visiting subscribers. The VLR is always integrated with the MSC. Authentication center, we know that a unit called authentication center, that AUC provides the authentication and encryption parameters that verify the user's identity and ensures the confidentiality of each SIM. The AUC authentication center protects the network operator from different types of fraud found in today's world. Equipment Identity Register is named as EAR. The EAR is a database that contains information about the identity of mobile equipment that prevents call from stolen, unauthorized or defective mobile stations. The Authentication Center and EAR are implemented as a standalone nodes or as a combined AUC or EAR. So the last segment is OSS operation subsystems that contains the EAR, AUC and operation maintenance control. That operation subsystem contains the operation and maintenance center that monitoring the traffic, subscribers, security, management and accounting bills that comes under the operations subsystems. AUC is nothing but the authentication center that provides the security, that protects the intruders, stores the user authentications, encryption provides encryption processes, equipment identity registers used to track the handsets using IMEI number in case of the mobile station is stolen. So with this note, I would like to conclude my sessions about the GSM architecture. Thank you.